Today we will discuss about the centroid. That is, centroid of an object is the geometrical center of that particular body. So for finding the centroid of an object, we are having two methods. First method is termed as method of integration. So we are today discussing the method of integration for finding the centroid of simple objects. For example, consider an object having area A. Set the coordinate axis, say y and x. This is x axis and this is y axis. Say its centroid is here. It is designated by capital G. X bar, y bar are the coordinates of centroid, means this distance from origin is your x bar, this is your origin, and this distance from origin is your y bar. So for finding the centroid, we are taking a small area dA whose coordinates are x bar elemental comma y bar elemental, means this is x bar elemental and this is y bar elemental. So by writing the moment of area about x axis and y axis, we will get the value of x bar as x bar elemental dA over dA, and for y bar it is integration of y bar elemental dA over integration dA. We will elaborate this by taking an example of finding the centroid of a right angle triangle. Suppose we are having a right angle triangle, say this is x axis, y axis, and this is a right angle triangle whose base is x, whose base is b and height is considered as h. Now say G will be lie here, x bar and y bar are the coordinates of centroid of that triangle. Consider an elementary strip like this at a distance from x axis, it is y, and thickness of this strip is taken as dy. The length is considered as b elemental, as it is b, so this is b elemental. By considering the similar triangle, this one and this one, we will write the value of this b elemental in terms of y as BEL upon B is equal to BEL upon B is equal to this distance, and this is how much? H minus y. So this is H minus y upon H, means B elemental is equal to H minus y by H multiplied by this B. So mind it, B elemental. We will use this in further equations. Now come to the finding x bar as integration of x bar elemental dA upon integration of dA. From here we can write x bar elemental. See here, for this elementary strip, its centroid will be its center here, and the coordinates of x bar elemental will be b elemental divided by 2, that is the midpoint of this strip. So x bar elemental is written as b elemental by 2 into dA. Area of this elementary strip dA is b elemental multiplied by dy. So b elemental multiplied by dy. Integration limits of y will be from 0 to h, 0 to h, divided by integration of BEL dy, that is dA, 0 to h. Putting the values here, 0 to h, take the 1 by 2 outside, in bracket BEL square. BEL is your h minus y by h multiplied by b whole square, BEL square multiplied by dy divided by integration of BEL, that is h minus y by h into b into dy, limit is 0 to h. Solving it by integrating this, we will have half, take the b by h square outside, b square by h square, integrating h minus y whole square, expanding it, h square plus b square minus 2hb dy 0 to h, divided by b by h, take it outside, b by h in bracket h minus y, integration of 0 to h minus y dy. That means b by h, you can cancel it, b by h 1 by 2 b by h in bracket h square into integration of 1 into dy, that is y, plus b square into y minus 2hb. I think there is something wrong. This is not b square, this is y square, h minus y square. So this is h minus y square 2hy. So we can write here h square y plus b, no, this is not b square, this will be y cube by 3 minus twice h y square by 2. 0 to h is the limit, divided by h into y minus y square by 2, limits from 0 to h. Now further we can say it is 1 by 2 b by h in bracket h square, y means h, that means it is h cube plus h cube by 3 minus twice get cancelled, h and h square, that means h cube, close the bracket, divided by h and this h, that means it is h square minus h square by 2. This h cube get cancelled. From here we will have half b by h into h cube by 3 multiplied by this h square minus h square by 2 means h square by 2, 2 by h square. So from here we'll have 2 gets cancelled, h square, this gets cancelled, and this h and h get cancelled, means we'll have b by 3. The value of x bar is your b by 3, means this x bar is what we'll get, b by 3. Similarly, for finding the y bar, we can take a vertical strip, like this at a distance x from here, having width dx, and this height is taken as yx, hx, h elemental. And by repeating the same procedure, we will get the value of this y bar as h by 3. Procedure is same for all. So we'll get the value of centroid for a right angle triangle as G is your b by 3 comma h by 3. Thank you.